Hello, my name is Craig Gallen. I have been a committer to OpenNMS for over 20 years, and I'm hoping in this series of tutorials to share some of my experience. This is session 1, and we're going to do a basic introduction to OpenNMS. Hopefully, you will have already seen the overview presentation on OpenNMS, which is in a separate video. Now I'm going to look at the exercises in session 1. All of the sessions are supported by material on Github, and I'll just talk you through how the repository is organized. You'll see that there are a number of sessions in the repository. These will cover each of the lessons we do week on week. But you'll also see that there is this folder called My Practice Coursework. Now, the principle that we're trying to apply with this is that you fork this repository into your own GitHub account, and then whenever you do any work that changes anything or modifies any of the configurations, you can keep a copy of that. But in order to do that easily, what I'm going to ask you to do is, when we work, say for instance on session 1, you copy it into your My Practice coursework, and that allows you to work on that and know that if I update any of the other sessions, whenever you come to merge those changes from my repository into your forked repository, there won't be any clashes because all your changes will have happened in this folder. Now, the folder itself contains a number of things. First of all, the session has the actual sessions themselves, but it also has this folder called Pristine OpenNMS config files. And this contains the etc. directory in a pristine state for all of the configuration for OpenNMS. So I will be referring to these files, but they're there in a pristine state for you to see as well. This will help you to navigate your way around the OpenNMS config. Also in this directory is a copy of the XSDs, which are associated with the XML files that are in the config. And the XSDs themselves give you some understanding of how to use the various fields within the XML files. So for instance, if I go to eventconf.xsd, this explains how the events are organized within OpenNMS and what all of the fields mean. So again, a useful place to go if you find fields you don't quite understand or that you want some more information on. You can go to these XSDs and find that information within the tutorials. There's one other folder that's worth talking about here, which is this workup folder. This basically just contains work that I'm working on as we go forwards. Just ignore this folder. It will change over time because as I fill out the later sessions, I'll be using that workup folder to do that, and then I'll copy the material into the session itself. And finally, it's worth just talking about this extra examples folder, where I will be putting some extra examples for things that we'll talk about in class, but which I won't have time to cover in detail. These extra examples will help you if you go there. So let's begin session 1 formally. And if I go on session 1, we can see that I have a presentation, which I've recorded a video of elsewhere, so you'll see a link to that presentation. Here's the link here. Please go and have a look. I won't go over it in this particular video. Now, I wanted to point out where you can find out information about OpenNMS. And the first place to go to get useful information is the OpenNMS documentation site. And you can see it's organized by version. So if I go to Horizon 33, which is the version that we're basing this tutorial off, you can see that all of the information on how to deploy and actually work in OpenNMS is provided for you in a fairly good structured documentation. So if there's something you want to find out about, usually you can search the docs and you can find information about it here. The next place you can go to find useful information is the discourse server, where a lot of members of the community ask questions or answer questions. and you'll find a lot of community support information here to help you find your way around OpenNMS. If there's something that you're unsure about, or a configuration you can't quite create right, go here and you'll usually find an example or something to get you started to help you with OpenNMS. Finally, we also have a chat server, OpenNMS Mattermost Chat. I actually have the desktop client for Mattermost here, and you can see, it has various channels in it, and you're able to communicate with members of the community. People are usually quite responsive with respect to Mattermost. So again, both the Discourse server and Mattermost are worth looking at. Now, if you have a support contract with OpenNMS Group, these channels are in addition to that support contract. So these are community supported channels, best effort. People will help you if they can. But if you have a question which you would think would be covered under commercial support, please ask that through your commercial support channels, and don't use these channels to get those urgent answers, because there's no guarantee you will get an answer through these community support channels. So how would we start up with OpenNMS? Well, the first thing we need to say is that there are various ways you can install OpenNMS. If we go to the install instructions, which are in the docs, there's lots of information here on how to get OpenNMS installed, and you'll see that for various different distributions of Linux, it's possible to install OpenNMS, and the instructions are here on how to do that, and there are various configuration options that it walks you through as well. Now, if you don't want to work your way through these instructions and you want to do something quickly, you can also go to a set of scripts that are held on OpenNMS Forge. OpenNMS Forge is a repository that contains lots and lots of contributions. There's over 138 contributions in here in various different forms. Stuff that the OpenNMS community has committed, but some of it in very good state, some of it in not such good state. So, use advisedly, but it's worth having a look around to see what's here, because it may be that what you want to do would be covered by examples in OpenNMS Forge. But the most important thing in OpenNMS Forge is this quick install scripts, where if you've got a APT Debian-based system, then you can run the script and it will install OpenNMS using the script. Or if you've got a RPM-based, you can also run a script to do that. And it basically follows the same steps as the installation and configuration guide and gives you good defaults to start up. So if you just want to install OpenNMS on a virtual machine or on a physical machine, and you want to do it without the use of Docker, then these install scripts, are one for Debian, one for Yum, are very useful. The other very useful thing on the OpenNMS Forge is the StackPlay repository, which contains many, many different examples of how to use Docker and Docker Compose to install OpenNMS. If I go to this full stack example, we can see that it's using Kafka. So we've got the Zookeeper and the Kafka broker, which are central to running OpenNMS. We have the database, that's Postgres. We have Elasticsearch, we have Cassandra, we have OpenNMS Horizon, and we have a Minion. And we have Grafana and Kibana, which is used to view Elasticsearch. So we've basically got everything here in a complete OpenNMS stack, but all contained within a single Docker Compose project. And you'll see if we go to StackPlay that there are many other examples. And these examples are generally kept up to date and should allow you a very good starting point for some of the more complex installations of OpenNMS. My examples follow the same pattern as the examples in this StackPlay, but have been specifically modified to help you do the tutorials with OpenNMS. So you can obviously use my tutorials as a starting point for various things, but the StackPlay provides you a vanilla version of these configurations that would allow you to get going with OpenNMS using Docker. So that really covers how you get information on OpenNMS. What I'm going to do now is proceed to the first exercise in this tutorial. And this exercise is contained in this minimal minion ActiveMQ. And if I open that up, we can see that we have a Docker Compose and we have a number of configurations for Horizon, for the minion, and for SNMP. Now, if I go back to the session, you can see that this is the actual network that we're setting up, for example. We have OpenNMS Core and Postgres on the same subnet, so that's your basic OpenNMS system. We have a minion, which is on the same subnet, so the OpenNMS Core can talk to the minion, but the minion itself has a couple of servers on the other side of the minion. These NetSNMP servers are basically little Linux distributions of NetSNMP on them, just enough for you to be able to do SNMP calls against these servers and get some useful information back. So we can see that in this example, OpenNMS Core can talk to these two NetSNMP servers directly, but it has to go through a minion to talk to these two NetSNMP servers. And if we go back to the configurations, the SNMP configuration is contained in this snmpd.conf, which is just a standard configuration for NetSNMP. Again, go and look at NetSNMP's documentation to understand what this is. The minion, very, very simple configuration. In this case, the minion location comes from this particular configuration item in this minion config.yaml. So whenever a minion starts up, it knows what its configuration is, and when it talks to OpenNMS, it declares itself as being this minion ID within this minion location, and OpenNMS will sit there and understand that that the minion is now talking to it, and this is where it is located. Various other little configurations here around what the syslog ports are and the trap ports are for the minion, but that's basically the main configuration. This line here, broker URL, points to the ActiveMQ, which is actually running in Horizon in this example. Horizon, as I've said in the main presentation, can run with ActiveMQ or with Kafka or with Google gRPC. In this case, we're using ActiveMQ, and this is the address of the ActiveMQ server, the port that's running on, and we also put in the address of the OpenNMS itself. So that's the minion configuration, fairly simple. The Horizon configuration is contained in here, and I will cover in more detail how Horizon is configured. I won't cover it in this particular session, but you can see that we've got a deploy directory into which you could put plugins, and we also have a overlay directory which overlays specific configurations for into the etc directory, and we can see that the OpenNMS ActiveMQ file has been overlaid here with configuration that allows ActiveMQ to be used within this system. So let's get this example running, and if we just go back up, we can see that we have our docker compose up command that we need to do. And I'm looking at the ActiveMQ folder, sorry, the minimum ActiveMQ folder. And I'm going to open the PowerShell here. We can start our Docker Compose project using Docker Compose up -d, and you can see in this example that it's already running. Now, in your case, it'll probably take a while to start up because it'll have to download all of the containers, but just to save time, I've already got it running in advance. Now, if you want to look at what's happening with the OpenNMS Horizon container, you can do Docker Compose logs -f, it just means follow the logs file, Horizon. And again, if you follow this, you'll see that it takes a while to start up. It will create the database and then run OpenNMS. But because the logs have stopped and we've reached this point where we've got the perspective poller running, we basically have an OpenNMS system up and running. And if we go on a browser to OpenNMS localhost 8980, then we will get this page where we just put in admin, and admin is the password. Skip the change the password and skip the other little pop-ups that happen, and we've basically got an OpenNMS system running. So at the moment we only have 2 nodes in this system. If we look at the nodes page, we can see that we've got a minion. The minion has started up and has declared itself to OpenNMS, so we can see it's in minion location 1, and we have a local host, which is the OpenNMS itself. Now, I want to discover what else is in this network. I know from my tutorial session that this is the network that I'm going to discover, but how do I actually go about discovering it? Well, if I go down, we'll see that we're going to go to the cogs. So this is the cogs here, and we're going to go to this configure discovery page, and you can see that you can delay the startup of discovery, and you can also set up retry so that the discovery will keep going over a period of time, or in fact discovery can happen on a regular basis as if it was on a cron job, but that can all be set up in these settings. What I'm going to do is to include a couple of ranges within my discovery. So I know what the ranges need to be, so I'm going to just go back to my tutorial and go down and see what they are. This is going to cover both the minion location range of addresses and the default range of addresses which are reached by OpenNMS. So let me start with the default, which is set here under location, and the begin IP address 192.20.0.1, 172.20.2.1. Sorry, I'll go in the .255. Sorry, confusion there. And I'm going to add that, and then I'm going to add another discovery range. Add new. Let's pull this over, and in this case the range is 172.20.2.1, so it's a different subnet. And in this case, we're not in the default, we're in the minion location. We're going to add that. So now we have 2 ranges. So I'm going to save that and restart the discovery. And over time, is it ready to do its rediscovery? So if I go on to nodes again, you can see it still hasn't discovered them, but if we look at the status and the events, we can see that a couple of events have gone in: discovery config change event, and then the reload daemon config successful. Basically, it's telling us that we have succeeded in setting up this daemon to go out and start collecting data about these new OpenNMS instances. Now again, it's going to take a while to do that because there's an initial delay, and then it has to scan through all 256 addresses on both of those subnet ranges to discover what it can. So it won't happen straight away. It'll take a little while. Let me just jump back into my Docker Compose, And what I'm going to do is just make sure that we can actually see those devices from my OpenNMS. So I'm going to log into the Horizon container. Now what this will do is it will execute a bash command in Horizon. So that will actually bring us into bash in our Horizon instance. And if I do an ls, you'll see these are the config files for OpenNMS. Now what I want to do is just make sure that I can ping the remote container. So I can do that by ping. And if I just find out what the address of the container is again, we can see that it is actually SNMP, NetSNMP 1.1. So I'm just going to ping that. And fantastic, we are able to see that device. So everything should work well. And I'm basically just doing this as a little delaying tactic, but I'm hoping that when we come back to our list of events, we can now see that nodes are being added and nodes are gaining service. So we're discovering nodes, and that's what we would expect as we're scanning the network. And under our nodes, we should see now that we have more nodes than we had previously. And gradually over time, this will build up. So as you can see, we've now discovered all of the nodes in our little network. Just to point out that the gateway is actually the address of the Docker gateway. That would actually be the gateway to the actual host that's hosting Docker, which we've discovered. And this 172.20.2.1 is actually the gateway in that particular subnet. But because Docker can't generate a reverse DNS lookup, it's just giving it the IP address. Now the rest of these devices have all been discovered, and OpenNMS has used a reverse DNS lookup to find the names of these devices. So this is the name that Docker is giving it whenever a reverse DNS lookup is made. And this is the NetSNMP 1.1, which is on the OpenNMS side of the network. And we can see we've discovered all of the services on that device. And if we looked at the resource graphs, probably no data in there now, but we'll graph the selection and see what's there. And it's still not really gathered anything because it takes every 5 minutes to gather data. So if we left this running, we would have data for the example. And you can see obviously in the example as well that we have got the other side on the other side of the minion, these devices being pulled to. And the final thing I'd just like to point out is that this screen that we've seen, Discovery, that is all backed by a file that is in the etc directory. So if I go back to the tutorials, we can see that that file is discovery configuration.xml. And what I'm going to do is I'm going to look for that within the OpenNMS. And you can see it's in the etc directory, so cd etc. and ls discovery configuration. And if we cat it, you can see that this corresponds to the configuration that we've put in on the UI. So you can post this file into OpenNMS using a REST API. You can leave it within the injected etc directory and it will discover the ranges, or you can use the UI to modify this file. So thank you for listening. That is the end of this first session. I hope you found it interesting, and we look forward to doing the next session with you next time.